Welcome to the Architecture Woodshop and Digital Fabrication Lab on the Marietta campus of Kennesaw State University. This video is about the measuring and marking tools that the shop has available to use. At the end of this video, you'll know about the shop's measuring and marking tools. You'll know what they're called, where they're stored, and how these tools are used. Measuring and marking tools are used to lay out measurements on materials that need to be cut or drilled. They can also be used to capture and transfer measurements. The category called measuring and marking tools also includes templates, tools that measure angles, and tools that would be used to transfer joinery dimensions. There are not any limitations on what material measuring and marking tools can be used on. It is good to keep in mind when marking material that the ink from some types of markers will penetrate wood or wood-like products fairly deeply, and this might not always be a good thing. Tape measures are one of the most frequently used tools to make dimensional measurements when working in the shop. They are typically flexible so that a relatively long measuring tool can be rolled up or retracted into a small portable case. Ruler is a slang name used to describe a rigid straight edge that has a scale printed on one or more edges. The shop has scales in varying lengths up to 4 feet. A square is the name given to tools that can be used to measure right angles and sometimes other angles. Combination squares have a sliding head that can be used along with the beam to measure distances or to lay out 90 or 45-degree angles. Combination squares can also be used to mark off a distance from an edge. A tri-square is a tool used for measuring the accuracy of a right angle. To try a surface is to check its straightness or correspondence to an adjoining surface. Japanese squares are a different kind of a combination square that is a combination of a 90-degree tri-square and a 45-degree miter square. Framing square is a long-armed square stamped out of metal that has 2 arms that meet at a 90-degree angle. Framing squares are typically used to lay out rafter angles related to roofs. A speed square is a triangular carpenter's marking out tool that combines the most common functions of the combination, tri, and framing square. It is typically used to make basic measurements on dimensional lumber. A T-square is not typically used in woodworking, but it is a drawing instrument used in drafting to make horizontal lines on a drafting table or board. The name comes from its resemblance to the letter T. A sliding T-bevel, also known as a bevel gauge, is an adjustable gauge for setting and transferring angles. The handle is connected to a metal blade with a thumb screw or wing nut. The blade pivots and can be locked at any angle by loosening or tightening the thumb screw. The bevel can be used to duplicate an existing angle or set to a desired angle by using it with any number of other measuring tools, such as a protractor or a framing square. A vernier caliper gives a direct reading of a measured distance with high accuracy and precision. These calipers combine a calibrated scale with a fixed jaw and another jaw with a pointer that slides along the scale. The distance between the jaws is then read from the scale. Vernier calipers have multiple jaws and can be used to make both outside and inside measurements. The thickness of material can be measured during thickness planing by taking an outside measurement. Vernier calipers can also be used to make an inside measurement of the width or length of a mortise cavity. In addition, vernier calipers can be used to measure depth by using a probe that is attached to the movable head and slides along the center of the body. This probe is slender and can get into deep grooves that may prove difficult for other measuring tools. A caliper is a device used to measure the distance between two opposite sides of an object. A caliper is similar to a compass and typically has either inward-facing or outward-facing points. The tips of the caliper are adjusted to fit across the points to be measured. A divider or divider caliper, popularly called a compass, is used in the process of marking out locations. A divider caliper is also used to measure a distance between 2 points. A divider caliper typically has points on the ends of both legs. A marking gauge is used in woodworking to mark out lines for cutting or other operations. The purpose of the gauge is to scribe a line parallel to a reference edge or surface. It's used in the layout of joinery. The gauge consists of a beam, a headstock, and a scribing or marking implement, typically a pin, a knife, a pen, or a wheel. The marking implement is fixed to one end of the beam. The headstock slides along the beam and is locked in place by a locking screw. To use the gauge, place the headstock against the reference surface and scribe a line with the pen as you pull the gauge toward you. A scratch-awl is a woodworking layout and point-making tool. The scratch-awl is basically a steel spike with its tip sharpened to a fine point. It can be used to mark a point by pressing the tip into the wood surface. It may also be used to scribe a line to be followed by a handsaw or chisel when making woodworking joints and other operations. The tip of the spike is drawn across the wood, leaving a shallow groove. This instrument is generally used when dimensioning and for laying out with the grain. It may also be used across the grain, but is not the preferred tool for that operation. A marking knife is used to scribe a line to be followed by a handsaw or chisel when making woodworking joints and other operations. A knife produces a very accurate line, which aids in making accurate cuts with the saw or chisel. Knives are generally used when laying out across the grain. Be careful when using a knife with the grain, as the grain can pull the knife offline, which produces inaccurate lines. The scratch-awl is preferred for long grain layout. If you need to borrow a knife, ask a staff person. We don't usually leave sharp objects just lying around. A level is used to indicate whether a surface is horizontal, level, or vertical, plumb. Levels have vials at viewing points. These vials are incompletely filled with a liquid, leaving a bubble in the tube. Marks on the vial help to indicate when the bubble is in a centered position in the tube. At slight inclinations, the bubble travels away from the marked center position. Vials have a slight curve in them, so the vial you're using should always be positioned on the top side so that it reads correctly. Scissors are available, but they should not be used to cut sandpaper. That destroys the cutting edge of the scissors. Never run with scissors. Actually, never run in the shop. The shop also has a limited assortment of abandoned drafting tools, such as T-squares, scales, triangles, compasses, etc. Don't count on the shop to have such tools available, but we might be able to save you a trip back to the studio if you're having a particularly forgetful day. If for any reason you think that the tool or technique that you're using is not getting you the results you need, please ask a staff member for some assistance. Significant safety concerns when using measuring and marking tools include the following. Tape measures have metal tapes. You can easily cut yourself on the edges of the metal tape, particularly if you touch the edge when retracting the tape. Don't make sharp bends with a tape measure. They can permanently crease or even break. Most tape measures have strong springs in them to retract the tape. Rapidly retracting the tape all the way can snap the end of the tape into your finger or jerk the tape out of your hand. Maintain control of the tape at all times. Some marking tools have sharp edges or points. Use care when handling knives, awls, calipers, etc. Handle them carefully. If the tool is a type that can roll off the table, it will. Sharp tools always land with the point down. Do not put your toes at risk. Some of the shop's utility knives have blades that are scored strips which can be broken off to reveal a fresh edge. Great care should be taken to secure the blade when breaking off a section so that it doesn't fly up and cut you or scar your safety glasses. When measuring and marking tools are used, keep the following principles in mind. Inaccurate measuring and marking will produce pieces that do not fit together, do not align, and will have unsightly gaps. Poor execution will undermine a brilliant design. Measure as accurately as you need to for the activity that you plan to do. Rough cutting to reduce the size of material so that it can be handled more easily does not need to be as accurate as cutting to final dimension for fit. Marking is as critical as measuring to the production of accurately sized pieces. The width of a marked line can introduce inaccuracy. Every mark has a width. While a dull pencil or marker may be fine for a rough cut, a narrower mark made with a sharp pencil or a knife is much more accurate for that finished dimensional cut. When you are marking a dimension on material, you're usually transferring a dimensional measure from a scale to the material, and this is an opportunity to introduce error. Take care to view the situation straight on and carefully align the marking instrument with the measuring tool. Remember that saw cuts have thickness. Don't forget to allow for the saw kerf during layout. For parts that fit together, transferring dimensions from part to part is more accurate than measuring one part and then laying out that dimension on the second part. The additional measurement step is an additional opportunity for error and inaccuracy. Whichever tools you use for measuring and marking, please return the tools to the appropriate storage area. Thank you for watching the video, and we hope you come to visit us in the shop sometime soon.